Learning goals. Welcome to this learning session on shipping pharmaceutical products. During hot and humid summer months in this course, we shall address heat and humidity fundamentals testing and data analysis industry standards and tolerances, humidity impact on packaging, summer shipping mitigation strategies. Understanding humidity and the heat index. Humidity significantly alters how we perceive temperature because it interferes with the body's natural cooling mechanism. In humid conditions, sweat does not evaporate efficiently from the skin, which prevents the body from releasing heat effectively. This phenomenon is known as the heat index, where a temperature of 72 degrees Fahrenheit can feel like 78 degrees when relative humidity reaches 70%. While humans feel warmer, it is a common misconception that humidity changes the actual air temperature. Meteorologists use the heat index to warn the public about the dangers of heat exhaustion and heat stroke during summer months. Understanding the distinction between actual and perceived temperature is the first step in managing pharmaceutical logistics. Experimental setup for temperature testing. To investigate if humidity affects temperature readings, researchers utilized a 64 cF environmental chamber set to a constant 40 degrees Celsius. Two primary tools were used: an Elitech GSP 6 Progelator, the portable data logger, and the chamber's internal Z+ sensors. The portable logger sampled data every 10 minutes, while the chamber sensors recorded data every 10 minutes, every 15 minutes to provide a comprehensive comparison. Environmental chambers are specialized pieces of equipment that can simulate extreme weather conditions by precisely controlling heat and moisture. These chambers are essential for stress test and pharmaceutical packaging before it is deployed in real-world shipping lanes. By maintaining a steady 40 degrees Celsius, the experiment isolated humidity as the primary variable. This section analyzes study results on temperature and humidity to understand their impact on pharmaceutical shipping. It highlights the importance of sensor placement for accurate monitoring. The study demonstrated that temperature remained constant at 40 degrees Celsius, even as relative humidity was increased from 50% to 85%. This confirms that humidity does not physically alter the air temperature within a controlled environment. Any slight variations in the humidity curves between the two sensors were attributed to their different sampling rates and physical locations within the chamber. In pharmaceutical shipping, this data is vital because it proves that temperature-sensitive medications won't face higher actual heat just because the air is moist. However, the study noted that the portable logger placed on a rack gave slightly lower humidity readings than the chamber sensors located in the upper left corner. This highlights the importance of sensor placement when monitoring cargo. Industry standards and tolerance limits. The study referenced the ISDA 3A test protocol, which provides a framework for the temperature and humidity tolerances allowed during parcel delivery. According to these standards, humidity readings are considered acceptable if they are within a plus or minus 5% range of the target. For instance, at a target of 85% relative humidity, any reading between 80 and 90% is within the industry standard limit. ISDA 3A is a general simulation test for individual packaged products shipped through a parcel delivery system. It includes various blocks of conditions, such as hot, humid at 38 degrees Celsius and 85% humidity for 72 hours. Adhering to these international standards ensures that pharmaceutical companies can reliably predict how their products will fare during global transit. Impact of humidity on packaging. Although humidity does not change the temperature, it poses a significant threat to the physical integrity of shipping containers. Most pharmaceutical products are shipped in corrugated cardboard boxes, which are highly susceptible to moisture absorption. High humidity can soften these boxes, leading to structural failure, crushed products, and potential exposure to the external environment. Beyond the box, moisture can penetrate primary packaging and cause medications to degrade chemically. This degradation can reduce the effectiveness of the drug, or in some cases, render it harmful to the patient. Maintaining a dry environment within the shipping container is just as important as maintaining the correct temperature. Mitigation strategies for summer shipping. To combat the risks of high humidity, pharmaceutical shippers must employ specific protective measures. The use of desiccants, substances that induce dryness by absorbing water molecules, is a common and effective strategy. These are often placed inside the secondary packaging to maintain a low moisture environment throughout the journey. Use of airtight or hermetically sealed containers to block moisture entry. Implementation of plastic over wraps or moisture barrier films for pallets. Selection of high-grade moisture-resistant corrugated materials for outer boxes. By combining these packaging techniques with rigorous temperature monitoring, companies can ensure that life-saving medications reach their destination in perfect condition, regardless of the summer weather. Summary: well done, you have completed the course Shipping Pharmaceutical Products during hot and humid summer months. You should now be familiar with heat and humidity fundamentals, testing and data analysis, industry standards, and tolerances, humidity impact on packaging, summer shipping mitigation strategies. Should you need to revisit any of the topics in this course, please use the menu at the bottom of the screen.